Imagine looking up at the night sky where the vastness above is filled with countless stars, each one a distant sun with its own story. For centuries humans have gazed upward, wondering what mysteries might be drifting between those stars. What secrets the darkness might hold. Now, picture spotting something truly alien. A visitor from another star system, a cosmic traveler that has journeyed unimaginable distances to briefly grace our skies. On July 1, 2025, astronomers at the Atlas telescope in Chile made a remarkable discovery. They detected a faint, fast-moving object on a trajectory that defied all expectations. Its path could only mean one thing. It was not from our solar system but from the vast interstellar void beyond. Named 3I/Atlas, this object is only the third confirmed interstellar visitor ever observed by humanity. Its arrival is a rare and extraordinary event, capturing the imagination of scientists and stargazers alike. Unlike anything we've encountered before, 3I/Atlas is a comet likely over 7 billion years old, almost twice the age of our sun. Its surface is rugged and frozen, a time-worn relic from the dawn of another solar system. It's a relic from a star that may no longer exist, drifting through the emptiness of interstellar space for eons before fatefully crossing our path. For billions of years, it wandered alone, untouched and unchanged until now. Hurtling at over 130,000 miles per hour, 3I/Atlas will only briefly visit our solar system before vanishing forever into the darkness. Its fleeting presence is a reminder of how vast and dynamic our universe truly is. Unlike Oumuamua and 2I/Borisov, the two previous interstellar objects, 3I/Atlas is much larger, about 3.5 miles wide. Its early discovery gives astronomers a rare chance to study such an object in unprecedented detail, using the world's most powerful telescopes. For the first time, we can closely examine a building block from another planetary system. Scientists are already poring over data, eager to unlock the secrets hidden within this ancient wanderer. This is more than just another rock in space. It's a chance to probe the chemistry of another world, to analyze the ices and dust that formed around a distant, long-lost star. Every observation could reveal clues about the origins of planets and the ingredients for life. Scientists are eager to answer profound questions, questions that reach to the heart of our place in the cosmos. Are the ingredients for life common across the galaxy? Could the same chemistry that sparked life on Earth be found in the dust of a comet from another star? Do other solar systems form like ours, or are there countless ways for planets and comets to take shape? 3I/Atlas offers a rare window into the diversity of planetary systems across the galaxy. 3I/Atlas is a time capsule from a different story of creation, now warming in our sun's light and beginning to reveal its secrets. As it approaches, its icy surface will sublimate, releasing gases and dust that can be studied in detail. The astronomical community is mobilized for a once-in-a-generation opportunity. Around the world, telescopes are turning to the sky, and scientists are working together to capture every possible detail before this interstellar visitor slips away, perhaps never to return. The confirmation of 3I/Atlas as interstellar sparked a global race. This was a fleeting chance. The comet would only be visible until November 2025, so observatories worldwide sprang into action. The Very Large Telescope in Chile captured its structure, Gemini North in Hawaii analyzed its chemistry, and Hubble refined its size. NASA's SphereX spacecraft joined in, searching for water ice and key gases. Data flowed in real time, with every observatory contributing to a comprehensive portrait. But the most anticipated observations would come from the James Webb Space Telescope. The world's astronomers waited for Webb's golden eye to reveal the comet's true nature. On August 6, 2025, the James Webb Space Telescope turned its powerful gaze toward a truly rare visitor, 3I/Atlas, an interstellar comet making a fleeting pass through our solar system. This was a moment astronomers had been waiting for, a chance to study material from another star system up close. Using its advanced near-infrared spectrograph, or NIR-SPEC, Webb carefully dissected the faint light streaming from the comet. This process revealed a barcode of chemical information, each line in the spectrum corresponding to a different molecule, allowing scientists to decode the comet's secrets. Webb's extraordinary sensitivity to infrared wavelengths meant it could detect even the faintest trace molecules, as the comet's ices began to vaporize under the intense sunlight. This vaporization released a cloud of gases, each carrying clues about the comet's origin and journey. The data was a treasure trove. Water, both as ice and vapor, was present, which was expected for a comet. But the details in the spectrum hinted at a more complex story, suggesting that 3I/Atlas was carrying a unique blend of materials. Carbon monoxide and other familiar compounds appeared in the analysis, just as scientists anticipated. However, as they dug deeper into the data, it became clear that something was off. There were unexpected patterns in the chemical signatures. One particular signal stood out, overwhelmingly strong and unmistakable. It pointed to a chemical composition unlike any comet we've ever observed, raising new questions about how such an object could form. The findings were so significant, so unexpected, that the research team decided to release their results to the world even before the usual peer review process was complete, eager to share this cosmic mystery. Webb's data didn't just add to our knowledge, it challenged the very foundations of what we thought we knew about comets and the formation of planetary systems, forcing scientists to rethink old models. 3I/Atlas was not just another icy snowball from the depths of space, it was a true chemical anomaly, a messenger carrying secrets from a distant star. The key to its strangeness? An abundance of one very common molecule, so ordinary in other contexts yet so bizarre and unexpected in this interstellar traveler, leaving scientists both puzzled and excited for what it might reveal. The shock came from carbon dioxide. CO2 dominated the comet's coma. In solar system comets, water is the main ingredient. CO2 is usually minor. But 3I/Atlas had one of the highest CO2 to water ratios ever recorded. This wasn't a small difference, it was a fundamental shift in composition. Scientists realized 3I/Atlas formed in a very different environment, perhaps near or beyond the CO2 ice line of its home star. Alternatively, its long journey through space may have stripped away water, leaving CO2 behind. Either way, it's a pristine sample from a different kind of cosmic nursery. This is direct evidence of chemical diversity on a galactic scale. 3I/Atlas offers a glimpse into the vast range of conditions that shape worlds around other stars. It's a comet unlike any we've ever encountered. The chemistry of 3I/Atlas forces us to rethink how planetary systems form. Our models, based on the solar system, assumed similar processes elsewhere. But this comet's high CO2 content suggests planet building blocks can vary dramatically. If comets like this are common, planets in other systems might have thick CO2 atmospheres from the start, changing their habitability. 3I/Atlas proves the raw materials for planets differ across the galaxy. Water is present, but the balance of ingredients is unique. Its immense age, over 7 billion years, means it formed when the galaxy was young and different. The comet is a fossil from a distant epoch, letting us study the chemistry of ancient planetary nurseries. It's rewriting the first chapter of the story of worlds. Our solar system may be just one of many possible outcomes. The origin of 3I/Atlas is a mystery we may never solve. Its speed and long journey make tracing its path back to a parent star nearly impossible. Over billions of years, countless gravitational nudges have erased its trail. The star that birthed it may not even exist anymore. 3I/Atlas is a ghost from a lost system, its address lost to time. This anonymity makes it even more compelling, a random sample from the galaxy. We don't know if its chemistry is typical or unique. All we have is the message it carries, not the sender. The only clues to its past are in its chemistry, revealed by Webb. It's a fragment of a story with the first page missing. The true horror of 3I/Atlas isn't danger, it's the fleeting nature of this encounter. It's not a threat that keeps us awake at night, but the knowledge that something extraordinary is slipping through our fingers, never to return. In the vastness of space, moments like this are heartbreakingly brief, and we are left scrambling to capture every possible detail before it vanishes. For a few months, we glimpse a piece of another solar system, then it's gone forever. This visitor, born in a distant star's cradle, travels for eons only to pass us by in the blink of an eye. We are granted a rare window into the unknown, a chance to study something truly alien, and then, just as quickly, it slips away, leaving us with more questions than answers. Such opportunities are rare. We don't know when another will come. Generations of astronomers may wait lifetimes for a moment like this, scanning the skies in hope. The universe is vast and these cosmic messengers are few and far between. This is a unique moment in science, slipping away with every hour. Every tick of the clock is a reminder that our time is running out, that the data we gather now may be all we ever have. The comet's bizarre chemistry unsettles our models, revealing a universe more complex than we imagined. Its strange composition challenges our assumptions, hinting at processes and histories we've never considered. It's like discovering a kangaroo after only knowing European wildlife. Suddenly the world seems bigger, stranger, and more wonderful than we ever thought possible. 3. I/Atlas forces us to reevaluate everything we thought we knew. Our theories must adapt, our understanding must grow, and our curiosity is reignited. The unsettling realization of our own ignorance drives us to learn more. We are reminded that the universe is not only stranger than we imagine, but perhaps stranger than we can imagine. For a moment, the galaxy sent us a postcard, a fleeting message from the depths of space, a reminder of how much is still out there, waiting to be discovered. The horrifying truth, we only get to read it once before it's gone. There are no second chances, no rewinds, only the memory of what we managed to capture. We're left to wonder when or if we'll ever receive another. Until then, we hold on to the questions, the awe and the hope that the cosmos will one day speak to us again. By late November 2025, 3 I/Atlas will fade from view, continuing its journey into interstellar darkness. But its legacy will live on in the data collected by telescopes worldwide. Scientists will spend years analyzing spectra, images, and measurements, searching for complex molecules and organic compounds. This work will build the most complete chemical inventory of an interstellar object ever. The combined data will help us model how such objects behave and evolve. Even after it's gone, there's hope for a final glimpse from spacecraft near Mars or Jupiter. The brief visit of 3 I/Atlas will shape planetary science and astrobiology for a generation. The discovery of 3 I/Atlas is a moment of profound cosmic perspective. For the first time, the galaxy has sent us a physical messenger from another world. Its alien chemistry and ancient origins remind us our solar system is just one of many. The story of creation here is only one among countless possibilities. 3 I/Atlas expands our understanding of what worlds can be. Its fleeting visit is a metaphor for our own brief existence in the universe. The urgency and collaboration it inspired show our drive to explore and understand. In the end, 3 I/Atlas is a gift, a glimpse into a different creation story. It leaves us with more questions than answers, fueling our curiosity. The universe is full of wonders, and we have only just begun to explore.